Okay, so let us continue. Up to now, we finished the two methods. Inverse transform, the general one. Composition, it doesn't mean not general one, but at least you should meet the form and then you can apply composition. And last one we call the convolution. Similar to the composition, this one the same. You should have the specific form and then we can call this approach to be the convolution method. Convolution, if we have an IID. IID random variable, follow the form sum of sum, and then variable x will be the convolution of individual y sub I. So if you have the form here, then it is called the convolution method. Well, for this convolution method, you should know the special. So sometimes we can call this a special property, and then this one special property or convolution. So if you know this specific property, it's really easy. Generate y sub I and then return sum of the y sub I, and that's all. Well, this is called the convolution. Because of the reason, x, if we want to calculate the PDF of x, it is the individual y sub I through convolution, then we can reach the calculation of a PDF for x. And that's it, right? Okay, so furthermore, m, so we have m-fold convolution, right? And also the algorithm, that's okay. And here we may have example 1. Previously, we understand Erlang. M stage Erlang actually can be individual y sub 1, y sub 2, and y sub n. And if we have individual exponential with the same mean, and the total mean is beta, so over m, then individual mean of exponential is beta over m. And I think you can through the discussion in chapter 6. You can understand this, right? So this is the first one. This is a direct example, explicit example. M stage Erlang can fit these. If we can fit these, you can generate exponential and then get a sum of the O exponential random variable. This one return the value. You return the value to have the M stage Erlang, and that's it. I think to this one, it's really easy, right? So almost okay, right? And let me ask how I'm okay for the current discussion for convolution. Okay, thank you. And next one, convolution. I should let you guys know previously about this, we have an inverse transform, right? Composition, right? And right now we have the third approach, convolution. So it says for the same PDF, it doesn't mean only one method. We may have multiple methods, but you need to check okay or not. So CDF, right? But right now, you should have this one, Y1 and Y2. Okay, and Y1 and Y2, then you return to this form. But the final form, you cannot tell it's the convolution, but using convolution, then you can have the final form. But for the final form, why? This one, why? It's u, so from 0 to 1, it's u, right? And right now, minus a half is 0, sorry, it's minus a half to, sorry. Let me correct. You want the range here. Here, I just try to check y1 equal to u1 minus a half. And another one minus a half. They are the same. So here, I just want to check. The y1 here, it's u1 minus a half. And then what is the possible range? The possible range actually should be a half to a half. Is it true? So this one later we can recheck. But why? Why we can follow the form? Uniform. Actually, it's a uniform and uniform. Uniform plus uniform results in a triangular. Is it true? So let me recap some of the results from the supplement. Wait a moment. Actually, this one is a half to a half, minus a half to a half. Right now, let me show you the results by using our supplements. Supplements, maybe it's 2. Sorry, not 2. Yeah, it's 2. Yeah, this one. So you can refer to supplement 2, example 8.3. Okay, so it's sum of these. But the range here, the range not the same as the previous range, but the range here it says 0 to 1, 0 to 1. So let me continue. So 0 to 1 for x, 0 to 1 for y. And then triangular should have the range 0 to 2. All right. So this one allows us to have these results. Uniform plus uniform results in the triangular and the range from 0 to 2. Am I right? Okay. So this is a result. It say uniform plus uniform results in triangular from 0 to 2 if previously 0 to 1, 0 to 1. Okay. So this is a current result. Is it okay? If it is okay, then go back to, let us get back to the discussion. This one. If you want to use y1, y2, still okay. Okay. Or maybe you can try these. Triangular. Okay, so we can have a uniform plus uniform to have 0 to 2. But you need to shift it. Shift. So this one called shift operation, right? So you can use the previous example to have the shift. Uniform plus uniform, it should be a triangular. -1, so you need to shift, right? Okay, so that's why we have these triangular, but the range from 0 to 2 to -1 to +1. So you can use example 8.3 of supplement 2 to understand this part. Here we only know the convolution for the first one, but we have the -1 to code the shift operation. Okay, so understand that one. If you understand that one, and right now you can use the current one to have the interpretation. Uniform plus uniform. But what is the range for this uniform? This one actually, this one uniform. And also another one uniform. And put them together, they have the extend from this one to -1, extend to +1. But this one, maybe we don't have the example. Perhaps will be harder for you to understand. So the best one, perhaps you can use example 8.3 to know this part. But you need to shift and then to have the version, this version. Okay, and then I think you will understand that this. All right, so about this, using example 8.3 will be easier. You understand me? So I think you just follow this one to have the direct result. If you want to use y1 plus y2, that's okay. It also follows uniform plus uniform. It will result in the triangular, this one. But you need to understand more by checking the similarity between the current version y1, y2 and the u1 plus u2 in example 8.3 of supplement 2. So I do not check the current one, but I want to check using example 8.3 of supplement 2. Okay for you? So Panka, okay for you? Okay. So I think if we make it easier, we just use example 8.3 of supplement 2. And then I think you understand we have a formula like this. And so that you understand triangular can be generated by two uniforms. If you have this and then it's done. Triangular, we can have 3 approaches, right? And that's all. So up to now, really special. Triangular can apply 3 methods simultaneously to get the way to generate the random variable. Amazing, right? I don't think you like it, but it's amazing. One variable can be generated by 3 methods. At this moment, we can understand 3 methods to generate the triangular random variable. Okay, so I skip some of the comparison, so you just check it for yourself. Okay, so two of the 2 use and 2 additions and etc. I think these you can check. Okay, so let me reach the next one. General approaches to generating random variables. Okay, so here we have acceptance rejection. It's really special method. So sometimes if you cannot use the inverse transform method, perhaps we will resort to the acceptance rejection because this is a possible way if it's really hard to have the inverse transform method. Okay, so look at this. This one, let's direct. All right, let's direct because we need to understand more, and then we can understand this one, okay, to apply. But you see, can be useful when the previous methods fail, right? Or they are inefficient. But we need to have a new function, majorizing function, T of x, larger than the specified PDF. So T of x here, original function here, original PDF here. Okay, so if all values of t larger than or equal to f of x, we can call function t of x majorized function f of x. So this is the requirement. We need to have t. For t will be an easier way to generate random variable, not the acceptance rejection. So we can normalize. So we can normalize so that we can have R of x. And R of x will be easier to generate its random variable. Well, if so, then we have the way algorithm here. Generate y follows R. Okay, so y here. Oh, sorry, y here. If we have a y here, you can substitute the function into the current value, ty, f of y over ty. So you have this probability. If you fall within the ratio, ratio actually meet the ratio property of u. So if meet, and then we accept, or otherwise we retry until we can accept one. And this one, it is called acceptance rejection. You understand me? So this is the current algorithm. It says not direct, but still acceptable. Why? So first of all, we should have R based on T. Do normalization. Once everything's ready, we can have the formula. And the same, we need to check why. Before we check why, we just let you guys know this. How about a T? It's a horizontal line. Then we have a uniform. Right? Once we have a uniform, we can try this, the ratio. This one and this one. So you can have the ratio. And this function, it is called beta. And later we will continue why that beta can apply acceptance rejection. But at this, your field seems to be okay. However, right now, let us have the proof for the previous algorithm. Okay, so check it. Right now, we can generate this when we can stop only acceptance, right? So condition acceptance, right? Acceptance, then you can generate random variable x when using y with acceptance. If we have this condition, we can have the conditional probability here, right? So we have the numerator and denominator. First of all, let us check First of all, let us check the numerator, right? Before we have the numerator, we can reverse it. How to reverse it? How about having a y and accept? So accept, then we follow this probability. So finally, we have this probability, right? So I think this is acceptable. Am I right? Okay, so this is the first one. Why? Because later we want to reverse the conditional probability by given the value of y. Why? Look at these. You have a range, right? But what is the possible value of y? The whole interval, right? Whole interval. So condition on y, and want to check these. Okay, so someone like this is a partition, but we choose the value y, and this is a continuous one, so we need to use integral. And because of a condition y, so we need to have the corresponding PDF. And that's all. So this one serves as the theorem of total probability. About this, is it okay? So let me stop here and check with you guys. Panca, for the current discussion, the current formula, can you accept? Okay. Jinting, okay for you? Okay, that's good. So I think you guys understand more. That's great. All right, so if we have the current discussion right now, let me erase some of the discussion. If necessary, I think you guys can get back to the video clips, and then I think you can understand some of the details. And right now, we try to have the partition for the interval. Okay, the partition of the interval from negative infinity to x, from x to infinity, right? If negative infinity to x, this one is the current range, but this one not the current range. So this one vanish, it's 0. About this one, understand me? Because we ask y lower than or equal to x. So greater than x, not the interval. So of course, finally it should be 0. About this part, is it okay? Diego, okay for this? So that we will have a single term. Okay, I think that's easy. All right, so up to now, we can reach this equation, right? Once we reach this equation, so we have this, but look at this. Look at this. This one, acceptance y of x. Okay, and given y. Look at this. It says we can use this. Therefore, we use this. In fact, we have the integral. So can we rewrite equal to this? Acceptance, and ignore this, so that we have a y. And etc. Is it okay? Because outer side specify the range. You understand me? About the actual equation, actual equality, is it okay? Jinting, you understand me? Okay, thank you. And how I understand me? Okay, thank you. If we have this, then we can apply the equation here. So that's why we have the equation here. And also we have a c, t of y over c to represent r of y. And also you can have the others. So finally, we can have this equation and cancel t of y. So we have a c, f of x over c. So finally, we can reach the results for the numerator. About the final result, let me check again. Pen card, okay for you? To reach the final equation? Okay, so at least if you want to have a note, at least you guys should have the actual equation. Because the range, so we can ignore these, right? So this is a critical point. If you know this, then you can reach the results. And likewise, let us check the denominator, acceptance. Acceptance can have the condition. Once we have the condition, that's really easy. We apply the previous one. So we can cancel these. And finally, this one is 1, so we have 1 over c. If we have these and apply the previous formula here, this one, so f of x over c and 1 over c, so finally it's f of x. So once we reach this, then prove it, right? So prove it. Well, up to now, we take a long time to prove it. But at least it says, finally, it's true. It's true to use to apply the acceptance rejection method. Am I right? So this is a maybe not quite long proof, but at least this is the details to prove the acceptance rejection algorithm. And finally, everything's okay to have the acceptance rejection algorithm. And that's it. So in the following or in the next week, we will continue. Or maybe later we can finish the example, but actually we will continue for sure because acceptance rejection will be frequently applied if some of the previous methods are not valuable, are not feasible, or not efficient, and then we can apply acceptance rejection method. Okay, so before we apply about the proof, is it okay for you guys? Howard, okay? And Darren, okay? For two of you, is it okay? All right. So I think if everything's okay, then we will apply the algorithm. So in the following, we will illustrate how to apply the algorithm. In fact, this one, it is an example. Okay, this is an example. Okay, so for this example, T here using 2, if you know beta with the maximum 2 at mode, okay, and then T of x actually is 2. And using beta, later we will have the function of beta. This one. Okay, and T equal to, oh, sorry, not exactly 2, sorry. This one. Okay, sorry, I failed to notice not exact. This is a constant, so you can have a uniform for R of x. Okay, so if so, the algorithm is really simple. Generate y, follow this u. Okay, and generate another u. So the two, they are not the same. Y and u are not the same. One for R of x, one for the current u. The current u, then we need to apply these. F of y over t of y, so that we have these, right? If we meet the condition and then return this y, or otherwise, go back to step 1 and try again. So this example, the simplest example using beta. So beta can apply acceptance rejection. As for why, beta 4 and 3 follows a formula. You guys can check chapter 6. Okay, so this is an example to illustrate the application of acceptance rejection. Is it okay for you? So you guys check it. Allow you guys to have 1 more minute to check this, and then I think you can realize, yes, it's true. This one meet the feasibility of acceptance rejection. Okay, you guys check it. Maybe you don't know why this. Okay, the same, you can check it. Okay. All right, so about this, is it okay? Okay, Panka says okay. And Diego, okay for you? All right, so I think almost all for you guys. So let me continue. Here we have the intuition. Okay, actually we will have the R of S here. Uniform. So uniform, right? However, uniform right now, if we check this vertical line, when it's really hard to accept this one, really hard to accept, right? So we'll try many times, and the sense around the center or around the mode perhaps will be easier to have these. So if you want to improve the rejection ratio, you can try to reshape T. However, not really easy. So not really easy. So is it better? You still can try, but we just let you know, still okay, but not really easy. All right, so let me stop here. And this one, I just want to illustrate original simplest one can be reshaped to the better one, but this one better. In fact, it doesn't mean better because not really easy, so you need to reshape. If you can reshape and like it, still okay, no problem. Okay, still okay, no problem. I think this week we reach this page, and next week we can continue the remaining discussion. Hopefully, we expect to finish all next week. Okay, and later I can check. Is it okay to have the schedule to the final exam? If yes, I will let you know through Moodle or maybe next week, or through the Skype. So probably we can finish all next week. So right now I can schedule the exam. If next week finish, so that you have 1 more week. So I guess maybe May 30. May 30 will be the final exam, the day for the final exam. Currently, under the estimation, is it okay for you? May 30 to be the day of the final exam. So if not okay for you, just let me know. So let me nominate some of you. Panka, May 30, okay for you to have the final exam. And Jinting. Okay. So at this moment, I try to get this done before, actually including and before next week, and so that we can using the current schedule, May 30, to have the final exam. And maybe you have a question, how about May 23rd? I will have the case study first. As for the schedule for the remaining, maybe I will recheck. Actually, we may have some discussion called part 3. If no time, maybe I may skip it. If we can have the discussion later, maybe I can reschedule, because I need to consider the oral presentation by you guys. The same oral presentation will be rescheduled, right? So let me recheck, and we'll post it soon through the Moodle system. You can check the calendar of the Moodle system, then you can realize how to have the rescheduled calendar. Okay, that's it. Up to now, I think we stop here. And next week, we can continue since page 42. And right now, if everything's okay, I will use May 30 to serve as a day to have the final exam. Okay, that's all. Any question? If no, see you next week. Bye-bye. Wait a moment. One student let me know, exam will be offline or online? Actually, I prefer online. Sorry, not online. Offline. You will come to classroom T4 403. Okay, so the answer is offline and using our classroom. I think up to now, according to the policy of CDC, this one will be okay, because we are not allowed to totally pass on online. Even we can use online, but I think come to the physical classroom will be better to take the exam. So that's why my decision is offline. Everyone comes to the classroom to take the final exam. And that's all. That's it. If no further question, see you next week. Bye-bye.